Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. To your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello future engineers. Here is another sample problem video in algebra, particularly on division of a line segment, distance formula, and angle formed that a line segment makes with certain axis, specified axis. So I hope that through these problems, your knowledge in algebra, particularly on the field of analytic geometry, will be enhanced and improved. And I hope that you will be a very good student in engineering in the future. So here we go. This is the problem. And by the way, allow me to present the solution in this manner so that I can discuss uh, three problems in a short period of time. For the line joining the points A at -3, 2 and B 4, -3, find A the distance AB, B the slope of AB, and C the point of division D closer to B that divides the line segment into the ratio 3:1. Then D in what ratio does the point of intersection with the x-axis, y-axis divide line AB. Then find the terminal points if AB is extended 4 times of its length. So let's plot points A and B first so that you will be guided as I discuss the solution. This is point A, which is at -3, 2, and point B at 4, -3. So these points are exactly located on the coordinate axis, provided coordinate axis. So for the distance, we apply Pythagoras theorem. Distance is, so write x, so 4 minus -3 quantity square plus quantity -3 minus 2 square. So 4 minus -3, 4 minus -3 is 4 plus 3 quantity square, then plus -3 y of b minus 2. So -3 minus 2 quantity square. So this is 7 square 49 plus 25 is equal to square root of 74 units. So distance AB is square root of 74 units. Then for the slope, it is this difference. So -3 minus 2 delta y, -3 minus 2, -5 over 4 minus -3, +7. So therefore the slope is -5 over 7. And if we check that line which is crossing the second and the fourth quadrant will have negative slope. So it checks. Then letter C, the point of division D closer to B that divides the line segment into the ratio 3:1. So D is closer to point B. So if the point is closer to B, it is somewhere here, then the ratio of the distance AB to that of DB is 3:1. So because the distance, the ratio is 3:1, this is point D, I'll call it x sub D comma y sub D. Then because this is 3 parts and DB is only 1 part, 3:1, then we imagine that point D is the midpoint between the midpoint of line AB and and point B. So the midpoint of the line AB is by midpoint formula. It is equal to 1/2 of the quantity negative 3 plus 4. So 1/2 of the midpoint is 1/2 of negative 3 plus 4. Then comma 1/2 of quantity 2 plus negative 3. So the midpoint M of line segment AB is at 1/2 comma negative 1/2. Point D is the midpoint between M and B. So by midpoint formula, XD is 1/2 of quantity 1/2 plus 4. So 1/2 of quantity 1/2 plus 4, comma 1/2 YD is 1/2 comma negative 1/2 plus negative 3. So simplifying, this is 9 halves. 1/2 of 9 halves is 9/4. So point D is at 9/4 comma negative 6 negative 7 halves. 1/2 of negative 7 halves is negative 7/4. So that's it. Point D is at 9 halves comma negative 7/4. That's the first analysis. The second analysis is the ratio of distance AD, because this is 3 parts, to distance AB, which is now 3 plus 1, 4 parts, is 3/4. So that distance, that ratio of distance is also the ratio of corresponding horizontal projection or vertical projection. So another solution for the ratio of for the x and y coordinates of point D, the point of division is that horizontal projection of AD as to horizontal projection of AB is 3/4. 3, then there are 4 parts all in all, so 3/4. So AD over AB is 3/4, then it is the horizontal projection, right x, xd minus left x negative 3 as to 4 minus negative 3. So xd minus negative 3 over 4 minus negative 3. So 4 plus 3 is equal to 3/4. So xd plus 3, this is 7. So xd plus 3 equals 7 times 3/4. 7 times 3/4 is 21/4. Then xd is 21/4 minus 3, and that is 9/4, which is the same as that. Then likewise, for the y coordinate, we have yd minus 2. So ratio of AD as to AB is also 3/4, and this time we use the y projection. So yd minus 2 over negative 3 minus 2, vertical projection of AB, is 3/4. So yd minus 2 equals 3/4 of negative 5 is negative 15/4. So yd is negative 15/4 plus 2. So that's why it's negative 7/4. So therefore, the coordinates of point D is the same, 9/4 comma negative 7/4. Next, part D, what ratio does the point of intersection with the x-axis, y-axis divide AB? First, for x-axis, the coordinates of the point of intersection of this line with the x-axis would be x comma 0. We know that y is 0 there. So we use the fact that the ratio of distance AX to distance XB is equal to the ratio of their corresponding vertical projections. I use vertical projection because we don't know the x coordinate, but we know the y coordinate. While the ratio of AY, this is the intersection of the line segment with the y-axis, coordinates of that point, I call that capital Y, would be 0 comma y. We do not know y. But this time, the ratio of AY to that of AB is equal to the ratio of their horizontal projections also. So let's have AY as to YB first. Sorry, AY as to YB and AX as to XB. So AY as to YB. So we have to obtain the ratio of horizontal projection. And it is 0, 0, x coordinate minus -3, then over for YB 4 minus 0. So 0 minus -3 over 4 minus 0, that's 3/4. So AY as to YB is equal to 3/4. Likewise, AX as to XB is the ratio of the corresponding vertical projection. So this is 2 units, obviously, and this is 3 units. X to B is the vertical projection is 3 units. Therefore, it is 2/3. So AX as to XB is equal to, if we use the coordinates, so we have 0 minus 2 vertical projection over -3 y coordinate here minus y coordinate of the capital X 0. So AX as to XB is 0 minus 2 over -3 minus 0. So that's why it is 2/3. Or it is obvious in this figure that this is 2 units and XB is vertically is 3 units. So that's why the ratio is 2/3. So that's the other way of explaining it. Then letter E, find the terminal points if AB is extended 4 times of its length. There are 2 possibilities. Call that terminal point 1, coordinates x1, y1. And this point here, we have a long break because it does not fit in this coordinates plane. So call that x2, y2. But we know that this is distance TA to A is 4 times distance AB, and distance from B to terminal point T2 is also 4 times distance AB. So for the ratio for the coordinates of T1, so ratio of T1A to that of AB is 4 as to 1. This is 4 times distance AB, and this is distance AB, so that's why the ratio is 4 as to 1. And it is also equal to the ratio of the horizontal projections. So to make the horizontal projection positive, so we have right x minus left x, -3 minus x1 over 4 minus -3. -3 minus x1 over, for AB, 4 minus -3. So -3 minus x1 over 4 minus -3 equals 4 over 1, which is 4. Cross multiply, -3 minus x1 equals 4 times 7, 28. So x1 is -3 minus 28, so x1 is -31. Likewise, for the y1 coordinate, we have, to make it consistent, so we have 2 minus y1 over -3 minus 2. So this is y projection equals 4 as to 1 or 4. So 2 minus y1, 2 minus y1, 2 minus y1 over -3 y coordinate here minus 2 equals 4. So 2 minus y1 equals 4 times -5, -20. So y1 is 2 plus 20. So y1 is 22. Therefore, the terminal point T sub 1 is at -31, 22. Then likewise for terminal point T2, distance B to T2 is also 4 units. Therefore, the ratio of BT2 to that of AB is again 4 as to 1, which is 4. So x2 minus 4, x2 minus 4, x projection of BT2 as to x projection of AB, which is 4 minus -3 equals 4. So x2 minus 4 over 4 minus -3 equals 4. Cross multiply, x2 minus 4 equals 4 times 7, 28. So x sub 2 is 4 plus 28, so x sub 2 is 32. Then likewise, for the vertical projection, y2 minus negative 3 as to negative 3 minus 2 equals 4. So y2 plus 3 equals 4 times negative 5, negative 20. So y2 is negative 3 minus 20. Y sub 2 is negative 23. Therefore, the coordinates of point T sub 2 when AB is extended 4 times its own length is at 32, negative 23. Then let's continue problem 33. Find the angle which the line segment joining the points quantity 2, negative 1 and quantity negative 3, 4 makes with the positive x-axis. So to find that angle, we find the slope and let's plot the point so that we can analyze it easily. So this is at negative 3, 4, so it is correctly plotted, and this is the point 2, negative 1. So from 2, negative 1 to negative 3, 4, this is the angle that line makes with the positive x-axis. And if we solve for this angle alpha, alpha is equal to 45 degrees because this is 5 units. To get 5 units, 4 minus negative 1, so 4 plus 1 is 5 units. For the horizontal projection, 2 minus negative 3, 5 units. And since it is sloping up to the left, so don't mind the sign. So this is arctan of 5 over 5, so that's 45 degrees, equal parts. Then if that's 45 degrees alpha, then from the positive x-axis, this line makes an angle of 180 degrees minus alpha, 180 degrees minus 45 degrees. So that's why it is 135 degrees. That is in counterclockwise direction, and counterclockwise is positive. If you specify it in clockwise direction, this is 45 degrees, but clockwise, then the angle that this line makes with the positive x-axis is 45 degrees clockwise, or simply negative 45 degrees. That may be the other possible answer. That is the other answer, negative 45 degrees. Problem 34. A line passes through points A, negative 8, negative 1, and B, 4, 3. Find the coordinates of the point on the line whose distance from A is 3 times that of B. So to help analyze the situation, let's plot points A, negative 8, negative 1. That's correctly plotted, and B, 4 units, 3. So that's also correctly plotted. This is the line segment joining AB, and D is closer to B because it is mentioned here the distance of that point on the line is 3 times the distance from B. So distance AD is 3 times that of B. So this is similar to problem 1, problem 32. So this point D is the midpoint of AB and B. So one way of solving it is to locate the midpoint of AB, then D is the midpoint of M and B. So I want you to solve that in that manner, similar to the first problem in this video, but I'll present the solution in this manner. So distance AD is 3 parts, while distance DB is 1 part. So that is distance from A is as to distance from B is 3 as to 1. And this ratio 3 as to 1 is also the ratio of distance of point D from A is 3 parts, as to the distance AB is 4 parts. So 3 parts plus 1, 4 parts all in all. So I'll use this ratio here because this is simpler to apply. So distance from A as to distance of AB is 3/4. Distance from A is the ratio of horizontal projections also. So it is xd minus negative 8. Then as to distance AB, which is horizontal projection, 4 minus negative 8. So it is equal to 3/4. So xd plus 8 equals 3/4 of 12. 3/4 of 12 is 9. Therefore, xd is equal to 1. Then for the vertical projection, the ratio is 3/4 also. The vertical projection of AD, this one, is YD minus negative 1. Then the vertical projection of AB is 3 upper y minus lower y negative 1. So 3 minus negative 1 is 4. And it is again 3/4. So YD plus 1 equals 3/4 of 4 is 3. So Y sub D is 3 minus 1, YD is 2. So that's why point D is at 1, 2. So if we present the solution in the manner I suggested earlier, so the midpoint here is negative 1/2, negative 1/2 of quantity negative 8 plus 4, so which is negative 2, and 1/2 of negative 1 plus 3 is positive 1. So this is at the midpoint of AB is negative 2, 1, while XD is the midpoint of this midpoint and B. So XD is 1/2 of negative 2 plus 4, so that is 1. So it's 1 here. And YD is the midpoint of, so 1/2 of quantity 1 plus 3. 1/2 of quantity 1 plus 3 is 2. So it checks. That's the easier solution instead. So that's it for this video.